Hi all, now we are going to explore a real-time scenario in data structure with the help of design thinking concept. Design thinking concept, we are going to apply all the 5 phases into a real-time scenario and we are going to solve that case. The case we are going to consider now is creating a family tree with the help of tree structure in the data structure. So let's start from the first phase, empathize.
Okay, in empathize phase, first of all, we have to know what people actually want. As we research around the people needed a simple and neat hierarchy towards their family. So, what they are currently using is a simple note or an spreadsheet just to watch their family trees. But it is very efficient for their small families. But for big families, it is simple.
During our interview, users said they needed a visual structure to track relationship. So members wanted to access members quickly, update details. So we thought of handling data structure. In data structure, tree data structure fits perfectly.
So now can you define the major problem we have identified in this case?
Yes, the problem statement we decided that how might we design a system that efficiently represent a family relationship in hierarchical structure where we can add or search or remove a person from this. We need to create a structure with multiple children under one parent, and it is not possible in array or linked list.
Exactly. So our main challenge was to create a flexible and dynamic model that can grow and shrink as the family data changes, and that naturally led us to tree data structure.
Now, can you specify some ideas to solve this case using Ideate phase?
First of all, we tried many approaches, and the first approach was to go with arrays. The backfall with arrays is that it can't efficiently show the parent inside the connections.
So first we considered linked list, but it represents only one-to-one connection. Then we move on to the tree data structure. It represents each node as a family member and edges as a parental relationship.
We also decided to use general tree structure, not binary, because we have more than two sides.
So let's see an example of a structure. So here the Ramu, the grandfather, he is the root node, and his children Ravi, Rani, and Raghu are the child nodes. And their children, that is the Ramu's grandchildren, Kavin, Kirtana, and Kishore, are the leaf nodes. So this shows multiple generations clearly.
So how can you generate a prototype using these 3 phases?
We implemented a small working model using Ideate concept, and where each family member was given a separate node using the structure.
So we developed operations like add chain to add a member, find member to search a member, delete a tree to delete a sub-branch, and to display family to display entire hierarchical tree.
To display the family, we used pre-ordered traversal for top-down display and level-ordered traversal for generation-based display. This makes it clear and very interactive.
So the prototype could add, delete, and display family members easily. And even after that, the relationship stayed intact after all these updates.
So good job with the prototype. What did you find after testing these phases?
We tested different cases like adding member, deleting branch, and searching the member. All worked well.
And we showed it to some users for testing purpose, and they said it is very useful and easy to understand, and it is most efficient to understand generation-wise people.
Some users suggest us to add photos, birth dates, or some personalized detail or tags to show them more personalized.
So overall, our tree-based model turned out to be efficient, flexible, and user-friendly, which is much better than the linear structures in our use case.
So in the conclusion, this project shows how design thinking can connect with technical knowledge in real world result. You identify a genuine user problem, explained idea created, and applied the tree data structure to solve it efficiently.